Great. Thank you all so much for being here. Without any further ado, we're going to dive right in. Got lots to share with you today. We have another incredible speaker that is going to lead another enlightening discussion on data centers and their impacts. Welcome to the fourth installment of The Exchange, Data Centers 101. Today, we will tackle the topics of the economics of data centers. I'm Dr. Natasha D. Jarnett of the Christina Lee Brown Environment Institute at University of Louisville, where I lead community engagement in the Institute and serve on the research teams of Greenheart Louisville and our Superfund Research Center. And it is with a grateful heart that I acknowledge my colleagues, Dr. Candy Walker and Dr. Joy Hart, who lead community engagement for Greenheart Louisville, and Drs. Ted Smith and Lauren Heberly, who lead the community engagement court of the Superfund Research Center. So this series is hosted by the Christina Lee Brown Environment Institute, and it's for a program that's called The Exchange, which brings together community engagement initiatives of both the Greenheart Louisville Project and the U of L Superfund Research Center. And we also want to thank Physicians for Social Responsibility for being a sponsor in this series. As we get started, I will note the opinions that are expressed by the presenters are their own and do not necessarily represent the views of University of Louisville or the Christina Lee Brown Environment Institute, nor do the use of logos therein indicate endorsement. So I am sad to share that we have lost a hero here in Kentucky last week, affectionately called Louisville's watchdog over our air, our water, and our land. We want to celebrate him as his reporting led to the start of a program that resulted in an 80% drop in toxic chemical emissions in Rubbertown, which is an area of Louisville that's home to 11 to 13 rubber manufacturers. And this community is known to be an area experiencing environmental injustice. He was an environmental reporter at the Courier Journal from 1999 to 2018 and with Inside Climate News since then. So we offer condolences and thoughts to his wife, Chris, his stepchildren and family, and also their cat, Moo, and all of their loved ones. I'll take a moment here for a moment of silence for Jim Bruggers. Thank you all so much. So as you know, we have a few goals within this series to have shared knowledge and exchange and dialogue and connect to resources and expertise, and also to understand multiple viewpoints, because the topic of data centers, it's varied. We're exploring 6 or 7 different areas of potential impacts, including health, economics, environment, policy, and communities. But there are varied aspects that could be addressed, and there are multiple viewpoints within all of these different aspects. So this group has been absolutely fantastic at maintaining respectfulness of the speakers and even respect within the comments. So please keep the comments coming, keep the questions coming in the comments, keep answering each other's questions and responding to each other's comments. It's a webinar series, and so as much engagement as we can have makes it even more exciting. And please keep sharing resources. And when we run into areas where we may disagree, be sure to respectfully address the issue and not direct it at a single person. All right, we have another Menti poll for you today. I believe we have 5 questions for you to consider, and we would love for as many of you to join this Menti poll as possible. This is another great way where we get to interact during this webinar series. I'm going to stop sharing and thank you, Eviana, for sharing the Menti poll. You're welcome to scan this QR code on the screen, or you can visit menti.com and enter the code 77877471. And we'll also drop the link in the chat. So I'm going to stop sharing, and Diana's got it pulled up. Right. So our first question is, we're still trying to get at where everyone is located. We've asked you what state you live in, what city you live in. We are very interested to know what type of area you in. Are you in an urban area? Are you in a rural area? Are you in a suburban area? And if you don't know, that's okay. You could say that as well. Someone asked for the link in the chat. I'm going to drop this link. All right. People are still joining, so we'll stay here for a minute. It looks like we're mostly urban or suburban, those who have joined. All right, we'll wait just a minute to see if there are additional people that are joining. So of those that have responded so far, it looks like that is slowing down. Most people are joining from urban areas. Maybe about half are joining from suburban areas, and there are a few joining from rural areas. Awesome. Thank you so much. So in our next question, we have it's 3 questions in one. Our conversation today is on the economic impacts of data centers. So to what extent do you believe that data centers will affect your household finances? So more so your individual finances. What about the local economy? And what about the national economy? Love to know your thoughts on how you think data centers will impact these different economic venues. Right. So most of you think that there will be a lot of impact on your household income and your local economy, but currently more so for the national economy, slightly more so for the national economy. Very interesting. Sarah has picked up on the interesting aspect of this question where we left it a bit open in a positive or negative way. It's a great question. And I think that's one for the group to decide and for you to think of and for you to consider. I think the implication of this is a negative impact to economics, but drop comments in the chat and share your thoughts on this as well to further expand. Right, it looks like most people that are on the poll have responded so far. The highest for national economy, then local, and then for personal finances. So this is a question. This is a right or wrong answer based on some recent research. What percent of Americans live within 5 miles of a data center? Right, lots of guesses coming in. I see some people getting close to the correct answer. Ooh, it looks like 1 or 2 people might have the correct answer if I'm if I'm giving a clue. Oh, very good. Thanks all for participating. Okay, let's see the answer. It's 38%. So 38% of us live within 5 miles of a data center. I suspect this is any type of data center, not only the hyperscale data centers, which has mostly been the topic of our conversation. Let's go on to our last 2 questions. They are similar, keeping the focus on the economic aspects of this. How do you think the potential impacts of hyperscale data centers could impact the economy? And you're ranking these in terms of which you think impact the economy most. And these are potential negative impacts. Our second question on that is on the beneficial impacts. So I'm going to wait before I start to say what the results are saying because I know they're going to be very dynamic and change by the moment. We'll give people a little time because it's your ranking, you're putting them in a ranking order, and you don't have to rank every item if it's one that you don't have an opinion about and doesn't rank high on your list. It's okay to only put in the things that you want to rank, right? See, we're getting close to just about halfway there on who's responding. And we know it takes a little time to rank 6 different items. So far, I would say utility costs, health, water use, and pollution are practically running neck and neck. Health and utility costs are going back and forth. Almost everybody has responded. Thank you all so much for taking time to respond. All right, great, great, great. So in terms of the ranking, it looks like number 1 is the utility cost. Second is health, which might be tied with water use. And then slightly lower, only slightly lower, is pollution. So those areas of potential impacts to the economy. And then we'll go to our last question. You're ranking these as well. Once again, the selections are optional. You don't have to select any to rank. But how do you rank the potential economic benefits of hyperscale data centers? And those could be around tax revenue, development, job creation, AI innovation and efficiency, geopolitical positioning, community investment, and then there's also an option for none. And so we'll give people a moment to rank or not rank. I'll let a few more people weigh in before I start summarizing potential results because they change so quickly. All right. Feel free to keep those results coming. We've got a majority of the results in. And so what we're seeing here is that among the potential economic benefits, AI innovation and efficiency is one that stands out. There are also a number of people that said none. That is currently our second highest response. Tax revenues and geopolitical positioning come after that, followed by job creation and development, meaning community development and community investment. I know there are some comments in the chat, and I cannot wait to get in there and see them. And thank you all so much for those that are dropping resources in the chat. We'll be sure to collect all of these. You are welcome to continue populating the survey, and we're going to move ahead with our webinar here. So I am going to share with you a video, and then we will introduce our speakers. So once again, we have a news story that takes place from a community or several communities across the US. And in PBS News Weekend, in their economic segment, they had a feature on data centers. So got about a 5-minute video to share with you. And then we'll introduce our speaker and turn it over to Michael Cork after this.
The EPA has reportedly drafted a plan to eliminate all limits on greenhouse gas emissions from power plants. That's according to documents recently obtained by the New York Times. The power industry is one of the top sources of U.S. greenhouse gas emissions, which scientists have said for decades help drive climate change. Now, with the rise of AI technology, demand on power plants is increasing, in large part to AI's reliance on data centers. Ali Rogan spoke with Kenza Bryan, climate reporter for the Financial Times.
Thanks for joining us. How would you describe the environmental impact of these data centers that are at the heart of AI?
Their environmental impact is huge and it's growing. AI data centers are massively contributing to the continued rise in power demand, which itself contributes to the continued rise in global emissions. And most importantly, it's growing faster than grid capacities. And even more importantly, it's growing faster than renewable energy growth, which means that even as data center energy use grows, clean energy from wind, solar, nuclear perhaps, is lagging behind.
And what have you learned about the public health implications of the capacity that's needed to power these AI systems?
Some of the public health implications are very local, but really the effects are more global than local. So pushing up demand for fossil fuels means more CO2 is emitted, which helps global temperatures creep up, which can have local effects through extreme weather events, for example.
What sort of regulatory environment is there for these facilities?
For the moment, there's very little regulatory scrutiny of data center energy use. And one of the only governments in the world that has started to take this seriously is Ireland and its own energy regulators, because they realize that some of the big tech companies that operate in Ireland, including some of the big US ones like Amazon, are starting to put immense constraints on its grid, which means it's difficult for local industry, for local houses to get the power they need. So they have proposed that when a new data center is built, it brings as much additional capacity to the grid as it takes away. But until those grid capacity constraints start to be felt more concretely in the US, for example, I think it's unlikely we're going to see specific regulations saying data centers have to bring more energy to the grid or have to bring more clean energy to the grid, particularly given that Trump wants to make the US an AI superpower. It wouldn't make sense at the moment to constrain that growth.
And in the midst of that growth, these companies that have these AI products and services, they are acknowledging the environmental impact, it seems, and they're talking about what they're doing. What are they telling you about the steps that they're taking to mitigate all of the impacts they're having?
Companies like Amazon, Meta, Alphabet, Google's parent company, they all claim accurately to be some of the world's largest buyers of clean energy now. So they make huge investments in wind, solar power, increasingly nuclear energy. The problem with that is those investments aren't always very local. So they might be investing in solar energy in Texas while they're consuming that energy somewhere else in a different US state. And critics of these big tech companies would say their promises don't always match up with the problems that local grids face and local people face.
And what have you learned about the debate over the merits of increasing use of AI in everyday life against the drawbacks that we've just discussed in terms of the impact on the environment and public health?
The AI boom has taken off at an awkward time for the fight against climate change because global temperatures are already rising much faster than scientists expected. And now AI, the International Energy Agency has said, is contributing to a massive increase in power demand, which itself is contributing to an increase in emissions. Because the problem is, we haven't decarbonized our grids yet. They're still hugely reliant on fossil fuels. They need energy even when the wind isn't blowing and the sun isn't shining, which means they're even more reliant on fossil fuels and those stable sources of energy like a gas power plant than other sources of energy demand.
Kenza Bryant with the Financial Times, thank you so much for joining us.
Thank you.
Right, let me power our slides back up. So with that, our speaker for today is Dr. Michael Cork. Dr. Cork is an environmental health scientist and biostatistician who earned his PhD from the Harvard T.H. Chan School of Public Health in December of 2025. He is the founder of Empower Analytics Group, specializing in translating energy infrastructure emissions into measurable public health and economic costs. Dr. Cork is best known for his research on the hidden health and economic impacts of powering AI and technology data. His research studies how on-site fossil fuel turbines and backup generators at data centers pump fine particulate matter into nearby neighborhoods, contributing to heart and lung disease. He advises communities and policymakers on the environmental impact of the energy infrastructure, such as mapping out the annual health costs associated with data centers. Now, Dr. Cork, I will say your ears have probably been burning for the last 2 weeks as both of our previous presenters, Dr. Latricia Adams and Aubrey Connor, have mentioned your work. So what you are sharing with us today is so highly anticipated. I am really excited to hand the floor over to you. You have the floor, Dr. Cork.
Awesome, thank you. And it's really great to be here in this webinar and see that there's a lot of really engaged people here. So I'm going to present today on some of the research I've been doing, both as a scientist and also through Empower Analytics Group, which is a consulting firm that I co-founded with Francesca Dominici, who's a professor at Harvard, in the attempt to kind of translate a lot of the science that we know about how our infrastructure and data centers affect health and how we can translate that into affecting decision making on this really tight timeline where we're seeing such a huge rise in data center infrastructure spend really quickly. So today I've titled this Why Health Impacts Belong in the Economic Conversation about Data Centers. And I'm first going to do a little bit of background for many of you. This will be kind of a review, but I think it helps gives a different perspective of how I like to think about the impacts of data centers. First, I want to motivate these health costs. So, right, I think many of you are aware, and I see that in this group, we have a lot of people who are concerned about or thinking about health. But I think in the general public, the concept of health impacts, and even in that presentation we just saw where they emphasize the local impacts can be small, but I would argue that actually the local impacts can be really large. So what if I told you the AI boom has a hidden health cost, and that cost is being paid in people's health? An example, there's one data center in Northern Virginia. We found it's up to $99 million in health damages every year. And until recently, nobody had any idea. So I'm going to return to this in a little bit, but I think it motivates why, throughout this presentation, I'm going to argue that health and the public health costs of the way we're powering AI belong in the conversation and are actually, I would argue, the only way we can attempt to get this right and mitigate some of these costs while still building towards a future that is aligned with human flourishing. Okay, so I'm going to talk a little bit about the AI digital world. And many of us, AI is a really useful tool in some contexts, and people use it for a lot of different ways, right? So a lot of us interacting with our phone, an app, ChatGPT, Claude, other services, we might ask it questions like, I want to create a dinner recipe, help me draft a text to my friend, help me with this email. A lot of kind of instances similar to how, the advent of Google and search engines, we have so many questions and humans love to questions and get kind of reasonable answers. The one thing that I want to emphasize, and this is something that, I think we need to contend with, is that every time we're using one of these apps on our smartphones or on our computers, this is not happening in the digital world. I think a lot of times it's hard to really conceptualize what is actually happening. How is it that when I ask a question to Claude or ChatGPT that it comes back with an answer? And the real way is through these data centers. So data centers are kind of the physical embodiment, the connection between our digital world and the physical world. And every time that we ask ChatGPT a question, I think to think about this is almost like we're mailing an instruction to a data center. A data center is running it on a computer or server there to answer that question and then sending back the answer. So it's almost like kind of a mailing service. And this takes a lot of energy. And right now there's very little understanding of just how much energy or how this impacts our environment. But we do know that these massive centers house servers and run 24/7 to power a digital world. So just how much energy do they require? I like to show this slide to give some context. So this is one really large data center that is planned in Indiana, 2.2 gigawatts. To give a scale of how much 2.2 gigawatts, that's 1.5 times more electricity than the entire state of Seattle. I'm sorry, in city of Seattle. And what's interesting about this, right, is the city of Seattle was not built overnight, but we're, within years, putting down infrastructure that is this scale of an entire city. And so that is going to cause a lot of really difficult constraints on the grid. There's a new problem that energy infrastructure is facing, which is large. It's essentially placing enormous cities, potentially in areas that are not used to having that much grid infrastructure. This is enough electricity to power roughly 1 million homes. And again, the data center, there's a wide variety in the types of data centers. These hyperscale data centers are the large data centers, and then these are the ones that often I'm talking about when I'm talking about huge consumers of energy. So one of the issues is that we have so much demand for energy, and this is something that was mentioned in the video, the grid is not designed to keep up. So the estimated increase in data center electricity demand by 2030 is 100 to 300%. It's such a rapidly increasing energy demand. And when our grid can't keep up, there's a growing trend of developers bringing their own energy. Now, on paper, that sounds great, right? Like developers should be paying for the energy that they bring to power these data centers. But the trend is also that they're going to power it through fossil fuel combustion and specifically using gas turbines and diesel generators, which run around the clock and can have less regulatory structure than traditional power plants. We just talked a little bit more about that, but it is, a lot of times these data centers, if they're using on-site power, is kind of like a power plant with servers attached. And we're starting to see this trend grow. So by the end of 2025, 39% of gas power capacity being developed in the US was designed to serve data centers on site. That's up from just 5% at the end of 2024. And this is only growing, right? So we're seeing a huge increase in the amount of natural gas that is being permitted or attempted to be permitted to power these data centers. And this has implications for the amount of emissions, global emissions of greenhouse gases, as mentioned, but it also has implication for local communities through the release of air pollution that is going to directly impact people living near these facilities. And the science on this, and this is something that I did my dissertation at Harvard on how increases in specific types of air pollution is linked to health, is very clear and well documented and studied over decades. So I'm going to talk a little bit more about that. But first, I wanted to just focus a little bit on the data center economics for a second. And right, what most data center debates focus on, and I think in the public discussions, focus on investments, jobs, and tax revenue. And those benefits, are real and drive a lot of the competition for projects. So there's a lot of talk about capital investment, construction operating costs, local tax revenue generated from these data centers that could help schools and other issues, and then the regional economic development. But what I've also found is that developers themselves are often focusing on a different set of questions. Those economics rely around electricity prices, grid interconnection timelines, transmission and substation upgrades, fuel sources and reliability, backup or on-site generation, cooling and water needs, and permitting and litigation risk. So increasingly, what is deciding whether a data center facility gets built is, do they have access to power? And I'm talking about electricity power here. So as AI electricity demand grows, data center economics become increasingly tied to power infrastructure. And to really see this, you just have to look at some of these, 10 years ago, it would be kind of wild to think, oh, these tech companies are suddenly turning into and investing massive amounts of money into power infrastructure. The idea that our big tech companies would be some of the biggest investors in nuclear energy, or even like this topic of renewables or fossil fuel infrastructure would have been kind of unheard of. But this is where we are now. A lot of big tech companies are honestly becoming huge power companies. And the reason is because of all the energy demand of these data center infrastructure. Now, in this talk, I want to argue there's a third category of costs that are currently being left out of the conversation, and that has really huge implications for how we construct these data centers. So the costs that are rarely accounted for include air pollution exposure, health damages, water scarcity, noise and quality of life impacts, ratepayer increases, right? What is the impact of putting so much, a hyperscale data center the size, larger than the city of Seattle in an area, and how we think about ratepayers and community burden. And so what I want to argue here is that health impacts are not outside economics, but right now they are being unpriced. So right now we know we have the science to determine how these this infrastructure is going to impact communities and also how it's going to impact the economics of health. And if that is not currently in the equation of our free market, then that is not going to be reflected in the way we're building this. And so there's really no hope of mitigating these costs or having a realistic picture of the impacts of data centers if we are not quantifying this. And that is exactly what I've set out to do as a scientist and also as a CEO of Empower Analytics Group. The idea is to provide independent science-based estimates of the health impacts so that we can try to build towards a better future where these costs are part of the conversation. I think that we've seen that community members and others, best health impacts is something we all really care about. So I'm going to give a brief introduction to what one of the health impacts that I focus a lot on, and that is fine particulate matter, which is a type of air pollution. The reason I focus on this specific type of air pollution is that fine particulate matter, or PM 2.5, is estimated to contribute to around 90% of the health impacts of air pollution. So when you're talking about something with air pollution and health, you really need to also be talking about fine particulate matter. And it's called PM 2.5, which sounds very technical, because of its size. So the 2.5 actually refers to a size in microns, and this refers to all pollution that is below a certain size. So it's very small particles. Well, small, well, it's about 30 times smaller than the width of a human hair. The reason it's really dangerous is that these particles are small enough to penetrate deep into the lungs and enter the bloodstream. And I want to emphasize that fine particulate matter, PM 2.5, is not something that is just generated from data centers. There's a lot of background levels of air pollution, of this type of air pollution. Often it's from combustion. This figure on the left shows this can be from the automotive industry, from the airline industry, from the agricultural industry, from wildfires, dust particles. There's a lot of different ways that particulate matter can show up in the background of our air. And there's a couple of things I want to emphasize about this type of pollution. One, there's no quote safe level of exposure. We as a nation set a limit on how much fine particulate matter we think is appropriate or is permitted as a national yearly average. However, the science is very clear that any increase in fine particulate matter results in an increase in health risks. Now, what does this mean? It means that there is no threshold under which it is safe, but we have collectively agreed at a federal level on these national ambient air quality standards, which are setting a limit. But we also know that any increase in this fine particulate matter in our environment will translate into increased health risks. And the reason we know that is because it's been really well studied through decades of epidemiological studies that include millions of Americans. Some of the work I've done is on the Medicare population, the entire United States. This is all 65 plus. What we've shown is that increases in pollution are linked to increases in health endpoints like childhood asthma, heart attacks, stroke, lung disease, premature death. And this has been repeatedly demonstrated to the point where the EPA uses causal language when we talk about fine particulate matter and its impacts on health. So this is a very well-studied pollutant, and we know that it increases the health risks of all these kind of different endpoints. And so I want to talk a little bit about how I measure health impacts when I look at a data center infrastructure, right? So if a data center is being planned in a certain area or has been constructed in an area, especially if it's using on-site power. So this is, again, burning fossil fuels 24/7 to power the facility. There's kind of 4 different steps that I do to estimate the health impacts and how we measure it. The first is we need to understand how much pollution is leaving the plant. And there's a couple of different ways that I can do this. Though one of the useful ones is that under the Clean Air Act, when you are building a facility that is going to emit pollutants, you need to have an air permit. And the air permit will determine how much pollution you are asking to much pollution might leave the facility. So we can use either the maximum amount of the permitted limit that is in this air permit application. Another way we can do this is we can compare to past or plants facilities that are similar and say, okay, we know a facility that is a similar size and a similar area emitted this much pollution. So we can estimate this is how much pollution will leave this facility. Again, it's important to note that we need to make a data-driven estimate of how much pollution is going to leave the facility. We then need to understand how this pollution is going to travel. Air pollution does not respect borders or boundaries. It can travel for hundreds of miles. And scientific literature has developed a lot of different peer-reviewed dispersion models to understand how pollution travels through space. And this is really important. So this is, we use a peer-reviewed model to estimate how air pollution will travel and impact the surrounding communities. And then we need to understand who are the people that are most affected. So we can look at US Census data and other metrics to understand who are the people that are going to be most impacted. What do they look like? How might this be different than the average American? And then finally, estimate the health and economic impacts. We use tools developed by the Environmental Protection Agency, or the EPA, that are linked to different health endpoints, as I talked about the last slide, and also use a federal evaluation framework to quantify the economic and health costs of these different health endpoints. The high level list is kind of the 4 steps we go through when we're looking at evaluating the health impacts of specific facilities. And now I want to walk into 2 specific examples that I've run. And at this point, I've done probably around half a dozen data center and kind of natural gas infrastructure projects. The first I want to focus on was the one I was talking about in the first slide, which is looking at the Vantage data center in Virginia. This is a on-site power data center and one of the first in Virginia. And for those of you who aren't aware, Virginia is actually a really interesting case because it is one of the data center capitals of the world. Loudoun County, Virginia has some of the most data centers per capita in the entire world. And so it's a really interesting use case to look at for the impacts of data centers, given that it is being impacted kind of before a lot of other places in the US or around the world have been impacted. So on the left, what I'm showing is I'm demonstrating a lot of things, but the star is where this data center is located. And on the upper right inseam here, you can see this is an outline of the eastern United States, just to show you what we're looking at. It's an interesting geographic area for those who are not familiar. We have Virginia. We also have Washington, D.C. and Maryland. Again, here is where the data center is located. And I've shown a bunch of different towns in the surrounding area. This is a pretty populated area. That's why there's a lot of towns. This is kind of the DC, Northern Virginia metro area. What I'm showing here is the result of our dispersion model. So for each town, I'm showing the estimated exposure to fine particulate matter attributable to this facility. And so what you can see is near the facility, and this is kind of intuitive, right? The closer you are to the facility, the more exposure to fine particulate matter. But we can also see that this exposure travels far from its source. It often travels a little bit farther east than west. This is given the kind of regional weather patterns. We also can see that it extends beyond just Virginia and beyond Loudoun County. So we can see this impacts areas of DC, of Maryland, and others. This area that's kind of has no color is actually Dulles Airport. This isn't saying there's no exposure here, but it's just saying this is not an incorporated town, so it is kind of like not shown. Okay, so how does this translate, right? This is the exposure to air pollution. How does it translate to the health impacts? So across the entire region of the affected area, we estimate that this facility will be linked to between 3 and 7 additional premature deaths per year. This range is reflective of how the EPA relates increases in exposure to health impacts. So it uses a low and a high estimate. And this also translates to $53 to $99 million in annual health damages. This is linked to 2,600 new cases of asthma symptoms annually. We also know that the people who are most affected are not necessarily, an average American. We know that the communities most exposed to this pollution have 4 times the share of Hispanic residents compared to the Virginia average. So it's disproportionately affecting Hispanic residents. We also know that this is kind of the same map as shown on the left, but now we're only looking at one county, Loudoun County, where this facility is located. This dot is where the facility is located. And again, on the left, I'm just showing the exposure of these different census tracts, the estimated annual exposure to fine particulate matter. On the right, as a comparison, the county itself produces a map of different environmental justice communities. And this is just to show that there's a large overlap between those areas that are environmental justice communities and the areas that are going to be most impacted by this facility. So here's one example of a data center using on-site power that before working on this, many residents were actually not even aware that it was using on-site power. It didn't require any sort of additional round of community comments when they decided to switch from grid connection to on-site power. The facility itself says that they are eventually going to try to connect to the grid, but that can take time. So for now, a lot of data centers are saying, well, what if we just brought our on-site power? Now, what I'm showing here is if we do not measure the health impacts, we're not showing some of the trade-offs that are happening from this type of facility. The last thing I want to say about this data center, the Vantage data center, is that this isn't actually that large of a facility. It's around 150 megawatts. So when we compare the 2.2 gigawatts, that's, this is like more than 10 times less, so 150 megawatts. So the reason that this is contributing a lot to health impacts is because of how densely populated this area is. When we talk about public health impacts, it's not just important to know how much the exposure is going to increase in a certain area, but also how many people live there. And this is all a question of risk. So if you're increasing the risk of these health impacts across a really wide area, I'm showing here, there's millions of people who live in this DC metro area. That's going to translate into big impacts because it's kind of a health game, right? If we have a lot of people that are exposed to it, even if the risk is relatively modest, we know that, it's going to impact people. Okay, I want to talk about one more facility. This is looking at the power plant that is being constructed to power the XAI Colossus 2 power plant. So this XAI Colossus 2 is being located in the Memphis, Mississippi area. So again, what I'm showing here is where we're looking. So this is Mississippi, Tennessee, and Arkansas. And again, this star is where the location of this facility is. This is a 1.2 gigawatt power plant. And just south of the border of Memphis, there's a couple of things. Again, what I'm showing here is the exposure of the estimated pollution attributable to the facility. What's interesting to note, again, is it does not respect borders. So some of the most impacted areas are actually going to be in South Memphis, despite this facility being constructed in Mississippi. And so from a regulatory standpoint, it's kind of an interesting one, right? Because this is being constructed right across the border, but some of the most impacted areas are in Tennessee and maybe have less of a say of determining how this facility is built. As the health impacts, this is linked to 2 to 3 additional premature deaths per year, up to $44 million in annual health damages. This is again something I want to emphasize, that though this is located in Mississippi, 60%, 64%, or the majority of the population exposure. So this is a measure of not just where it's increasing exposure, but who lives there. It's going to fall in Shelby County, Tennessee, which is where Memphis is located. And the reason is because so many people live in Memphis, right? So they're going to be, the people who are most going to be inhaling this pollution are going to be in the Memphis area. We also know that the most impacted areas are overrepresented of Black Americans. 73% of residents in the highest exposure areas are Black, which is double the Mississippi average and far above national levels. We also know these communities already have higher asthma rates, which is an important factor because we know that people who have asthma are more likely to be impacted by more air pollution. They also have high social vulnerability, which is a measure that kind of shows how likely or how able a community is to absorb an additional exposure or stressor, such as this air pollution. Now, for this particular study, and this has actually been something that has been in the news recently, kind of unrelated. There's currently a lawsuit going on between the NAACP and Southern Environmental Law Center and this facility for other reasons, but we're seeing that there's a lot of kind of political fighting or infighting happening around this facility. I was able to present these results to community members with Tennessee State Representative Justin Pearson. And what I saw there is that communities are really engaged in this and really find this a really important issue and are really often lacking the scientific tools or the information so that they can have a clear understanding of what are these health impacts, right? There's an understanding that, these facilities could impact our health and impact our water, but there's often very little clear, hard data that is independent, right? This is not generated from industry. And so there's such a clear demand for having this health accounting enter the equation. So I want to end with talking a little bit about the economics of this infrastructure. So we know that in data centers in the US, there's around over $3 trillion invested. And honestly, this is probably not in date. Like these numbers are always changing. 1.1 trillion of it has already been built. We have over 5,000 facilities that are running different types of data centers. We know there's tons of money being invested in the construction of these data centers. We know that more are coming, right? In the pipeline, there's kind of an immense amount of data centers that are being constructed. And we also know that these facilities can operate for decades. That means that right now, there are decisions being made that could lock in our air quality and our community's health for a generation. And what's concerning to me is that these decisions are being made without any systematic health accounting, right? So the work that I'm doing here, that is not typically being done at any level when we're thinking about permitting a new data center. And what I argue is that our current permitting framework applies a patchwork of existing standards to a new type of facility. So often the question that are asked to regulators is, does this project comply with standards which are often defined for a different era? They're not used to a trend of kind of rapidly needing to increase the amount of energy we produce. And what I think is missing from every permit review is what are the health costs of people living nearby. There's a lot of critical gaps in understanding the health impact. This is cascading effects, right? Nobody's asking about health impacts before permits are granting, or I'd say very few people are asking about health impacts. So communities are often left without the information they need. Regulators lack standardized tools to understand, what is it that we should be asking from data centers or developers when they come to a different facility? How should communities be asking for specific um, implications of a data center coming to their town? It also means that if we're not measuring health impacts, then developers who are taking more time to think about cleaner energy solutions or ways to mitigate some of the harms in terms of air pollution, but also in terms of noise and water use are not being incentivized to do that, right? We're not creating an incentive structure where that is even being valued. And so this means that, we are not really, the health implications are not being seriously considered in the current permitting framework. Believe that independent science-based health impacts are necessary to fill this gap. One of the things I really believe is we can't change something we haven't measured. And so this is something I feel really strongly about. I'm going to talk for a second about just the work that I've been doing as an independent health impact assessment. So Empower Analytics Group is what we do is we produce these independent analyses that quantify the health impacts of AI data center infrastructure. Right now we help communities, environmental groups, and regulators ensure health impacts are part of every decision. We're also open to working with the developers who are committed to leading on health and kind of mitigating some of these harms. I think one of the ways that we can solve this problem, this is a problem that I think requires a ton of creativity and a lot of different players. But one of the ways that I can contribute is we know that the science is very clear about how we can put together credible, defensible science on estimating the health impacts. And this is relying on really established methods, including those by the EPA and federal health agencies. And what we've seen is that this data is really powerful, right? Communities really care about this data, and this has led to already kind of some instances of kind of changing from a natural gas technology to maybe finding other ways to power data centers that mitigate a lot of these health impacts, like renewable energy, like fuel cell technology, and has also led to a lot of kind of engaged people who are trying to think of different ways we can meet this demand. Okay, I want to end here, which is I like to end my presentations by trying to envision and put forth a vision of our AI future or AI growth that is more in alignment with community health, because I think that is definitely possible. We need visionary leaders to try to imagine a different way. And one future that I want to lead towards, and I've kind of, for communities, here's what I think should happen, is that before any proposed data center is built, we need to have an understanding of the independent health impact assessments. The reason is with that information, communities are more empowered, but also more able to see what are the benefits and trade-offs of specific projects that are being proposed to them. For developers and regulators, we need credible science-based health analysis that will help create a level playing field and give responsible developers credit for building cleaner facilities. If right now the biggest bottleneck is power, and we're not any sort of way of meeting that power demand is equally weighed, then we're not going to necessarily get a solution that is best for our environment and for our communities. So I think that including this is a really crucial aspect. And then finally, for all of us, I think we all envision a world where AI can grow responsibly and in a way that is in alignment with what we want. So AI can grow, communities can thrive, But I believe that this is only possible if health and many other factors is part of their calculation from the start. So thank you all for listening, and I'm happy to take some questions. I also have some links to some of the other work we've done. Um, and another great way to find some work we're doing, I'll post this in the chat, is through our website, empoweranalyticsgroup. So thank you all.
Absolutely wonderful. You can hopefully see, Dr. Cork, that there are some emojis showing on the screen, and folks, please keep those coming to show appreciation to this excellent speaker for sharing the incredible research that he and his team have undertaken. This is just so interesting, and it's drawn a lot of questions in the chat already. So I'll try to get to those, as many as we have. But I want to recap some of the things that you shared that stood out to me. That we need to keep in mind that there's no safe level of exposure to PM 2.5, and it has tangible health outcomes that have been very well documented. That pollution doesn't stop just at the fence lines. There are evidence-based ways to measure the health impacts. You've taken us from Loudoun County, Virginia to Memphis, Shelby County, Tennessee, and Mississippi as well, to understand what some communities are experiencing. And I think to a big point that the health impacts are not being considered in permitting, and how important that is. I appreciate the optimism that you shared that there can be AI growth that is more in alignment with community health. And that before building, we need these health impact assessments. My screen is changing a little bit and it's a little bit frozen. Hopefully that's not what's happening for everyone. Hopefully that is just on my end. I'm going to muddle through. I have another way of sharing the questions and comments that have been received with you. But there was some commentary from Andrew and others about there being benefits of data centers, but renewable systems not being in play currently. And a response to Andrew from Khalil that, we were told it must be built through scaling. Do you have any thoughts and insights here on renewable opportunities and potential benefits to the economics and health?
Yeah, I think that's a really great point. I think it's absolutely true that right now, that we are not, a lot of the ways that we're powering these data centers is through fossil fuel generation. And I want to emphasize that at a high level, I focused on specific facilities that are using on-site power, and this is a
Yeah.
growing trend. But most of our facilities are powered through the grid for now. And I think an important thing to mention is how we power the grid. That energy mix really depends on the region you're in. The different regions have different levels of renewables that are connected to the grid. So any ability that we can have to increase the amount of renewables that are powering our grid, and also by extension our data centers, would mitigate some of the health impacts. I want to also emphasize that this is a really complex issue, right? So at the scale at which we are developing data centers, it's even hard to imagine, given our technology on renewable energies, just how much would be required, right? Even if we were to use solar energy and wind energy, it would require a massive expansion of these technologies. And we know that each of these has implications, right? If solar energy requires a lot of land use, wind energy requires a lot of siting and can affect wildlife. And so I guess what I think I will need to emphasize here is that this is a really complicated issue with a lot of nuance. And so one way that I like to think about it is we have to start walking down a path where we're trying to get it more in line with the environment. That path, we don't have to have the answer right now, but we need to know what is the next best move. And a lot of us have expertise to start that. For me, what I think a lot about is the way to start this path. One is we need to make sure that when we're thinking about the impacts, that these health impacts, the impacts on water and clean water, the impacts on noise, all these impacts are being measured and part of the conversation. Because only through getting them in the conversation can we start having innovation and creativity to find ways that we can meet some of these demands that also, make sure we don't meet meet this economic development at the expense of our communities and our air. So I guess I want to just honor this is a really complex issue, and it's hard from our vantage point to see how this is going to resolve. But I do think it is only going to resolve through all of us taking small steps in a direction where we know that this is going to help push it in a direction where communities and health is being honored.
I love that, where communities and health are being honored. So another question, and this is just a point of clarification, but I want to make sure that those who tune into this recording afterwards hear it straight from you. It's been answered in the chat, but early on you shared about data centers that consume 1.5 more times electricity than the entire city of Seattle. And what unit is that? In the chat, it's been answered annually. Just want to toss that to you.
Oh yeah, so that's here. So this is in terms of capacity, right? So I think what this is saying is, if we're planning one of these, this is one of the larger data is an Amazon data center campus in New Carlisle, Indiana. So feel free. I don't think there's another question about this data center. Feel free to look it up and see this information. This is the same amount of capacity as 1.5 times the capacity of the city of Seattle. I'm pretty sure that is what it's measured. So this is the amount of kind of raw of power that is required. And another data center that's been recently in the news is the Stratos data center in Utah, which is a proposal for 9 gigawatts of power. So that's just kind of showing, I think that many of us are, unless you're an electrical engineer, which I'm not, aren't aware of just how large the scale is. And I think seeing that and comparing it to these cities really gives you an understanding of, one, how challenging this is to implement, but two, that yes, this, without really careful consideration, there's many ways that this could really impact a community if you're building that much capacity nearby. And so kind of, again, I think it just motivates that this is going to require a lot of, people who are thinking about the unintentional impacts of these facilities. And right now, a lot of usually it's kind of just build these as quickly as possible. And we know that can have negative impacts.
Absolutely. I'm going to try to squeeze in two more questions. There are so many questions here for you, and we'll make sure that you have them. But how are other countries like China and others accounting for the health impacts of data centers? And are there any lessons that can be learned in other countries or elsewhere?
Yeah, that's a really great question. And honestly, I don't have a ton of knowledge of the specifics of how other countries are handling it, but I can speak in generalities, which is, we see China is a country that's investing a lot in its renewable energy infrastructure. No country is perfect on this, and I would argue that I doubt, I haven't seen a ton of the health impacts being part of the essential part of the conversation, but we know that there are places in Europe that are starting to think about water regulations as well. And so, again, just having an understanding of how data centers impact not only how much water is consumed, but also how much of our water maybe is polluted or not through these data centers. So I think that at a global level, it's really useful to look at how other countries are doing it, because this is a new technology that again, the regulations have not caught up to these changes. So we need to maybe collectively decide what are the ways that work, and to try different things and see if they're accomplishing our goals.
Wonderful. I have lost access to the chat again, but the question I wanted to round things out was your thoughts on potential health impacts to water, and how that informs analysis as well, and agriculture too.
Yeah. The water is another, I've started doing a lot of the work that I do through air pollution because this is what I did my entire PhD in. And I think it's a really well documented, and, there's a way to connect air pollution to health that I think is really impactful, and people really want that information. I think water is another one that's really important to measure, which is understanding how much water is required, and also I want to emphasize that like water and air pollution and all the impacts are actually deeply connected, right? So even if we start to silo them into the impacts on air or impacts on water, they're actually deeply connected. And one way to think about it is actually, a lot of the technologies to maybe reduce water consumption might require more energy. And that energy might be being powered through fossil fuel, or that energy might require water itself to power. And so again, it's just to remember that all of the things are interconnected. And one thing I like to remind people who are interested in getting involved in this area is that it requires so much different expertise. Um, and
Yeah.
water is something that our Empower Analytics group and my research is really interested in getting into. It's a hard question because we're in an area of a lot of data scarcity. I think that's what a lot of researchers notice is we don't have a ton of data on this, and so sometimes we have to really, with what the best we can, kind of try to understand and over time refine that estimate. So that is something kind of to look forward to. Is that something I really want to emphasize more? And there are other people that are really interested in understanding how water is, such an important resource that is currently we don't have enough information on how that's impacted through data center infrastructure.
Yeah, water is challenging for a number of reasons, but water is life. Okay, I said I was only going to ask you two more questions, and we're over on time, and I want to respect everyone's time, but we've gotten a few questions on the topic of heat. Um, Here in Louisville, we have one of the fastest growing urban heat island effects in the US. Thoughts on heat in these analyses as well?
Yeah, that's another really important impact. We know that, actually heat and fine particulate matter, even they kind of, there's a, oh, both can actually impact health, right? So if you're at a higher heat, there's actually can be more of there can be an interaction between the two.
Mhm.
We know also that, burning methane or different types of natural gases increases heat. There's, I think, pretty well documented work on this, for some of the work in Memphis area. So again, and we know that increasing the amount of emissions, which is happening through AI and also, other things, is heating the planet. So I think there's a lot of really important ways to focus on heat, and it's something I am not an expert on, but I think it's a really excellent point of all these different potential impacts of this transition to AI.
Yes, and I think that the way that you connected, that it's all connected, which this then requires so many different areas of expertise, including lived expertise, to be at the table to inform decision making and to understand potential impacts. There are some questions about how this may affect the bourbon industry, which is quite important in Kentucky in the chat. I'll just draw your attention to that as well. I am scared to click anything on my screen. But I would like to direct everyone's attention to our survey so that we can hear from you and continue to shape these webinars. We are so grateful to you, Dr. Cork, for taking the time to share your analysis, your expertise, your insight. Please send emojis on the screen showing appreciation for the insight and knowledge that has been shared with us. And also, please stay tuned for next week. Next week, we will learn about data centers and the environment from a team of researchers in the Environmental Co-Laboratory at Drexel University next week. That will be July 1st. Hard to believe that we have already completed a June of webinars on this topic. July 1st at 1 o'clock, we will learn more about the environmental impacts of data centers. And then I want to pause for an announcement. Dr. Heverly, Chair of Sociology here at University of Louisville, there's another opportunity for people to learn more about data centers. Are you able to share?
So I put the information in the chat, and so folks can take a look at it there. It's connected to the work that the Kentucky Resources Council does with connecting energy and environmental quality. They are having a conversation with the energy utility costs and affordable housing. So within the residential conversation, that is clearly connected to the impacts data centers may have in their energy hoarding, energy usage. So the link to the event is in the chat for folks.
Fantastic. Thank you. Thank you to all those who have shared resources in the chat. We've taken note of these and we'll be saving this chat. Again, we're creating a resource library. We'll definitely be happy to feature Dr. Cork's work in our research, in our resource library that we will share at the completion of this series. If you have other resources to share with us, we are glad to add them. Thank you so much for your time. We look forward to seeing you next week.
Thanks all. Bye bye.